All right, so we're going to take a look at section 7.4. And 7.4, the first thing we're going to look at is combining terms when you have terms with radicals. And the idea is this: we can treat terms with like radicals as if they're like terms. So like radicals are like terms, and just like we combine like terms, we'll combine like radicals. So for example, excuse me, let's say we have 7 radical 3 plus 2 radical 3. Well, we're going to treat this as a radical 3 term. So this would be like an x, and this would be like an x. So like 7x plus 2x. So we'll get 7 plus 2 radical 3, or 9 radical 3. So let's say we have something like this. So again, what we're going to do is we're going to combine like terms by combining like radicals. So we'll get 3 square root 13 minus 2 square root 13 minus 2 square root 5 plus 4 square root 5. 3 minus 2 is 1 square root 13. Negative 2 plus 4 is 2 square root 5. And just like with, say, x, where 1x is x, because same thing with this. So for our final answer, and that's going to be it. Now, because these are different radicals, they're different terms, we don't try to combine them. So let's say we have this. Now, we have 2 types of radicals here, the 7 and the x. Now, there's reasons why these are different radicals. For one, it's different elements in the radical. Also, it's different types of roots. This is a root 2 and that's a root 3. So 2 reasons why these won't combine. So 6 plus 2, 8 square root 7. This is a minus 1 and a plus 5. So plus 4 root 3x. And that's it. So let me do one more like this. Let's say we have this. Now again, we have two types of radicals. Here, we have an x. Well, we have an x here, but these are different roots. These are different radicals. So that means this type and this type won't combine. So what we'll get is 2 square root x, 9 square root x, 7 cube root x, or 11 square root x, 7 cube root x, and that's the best we can do. All right. So let's take a look at this. Sometimes we got to do a little simplification first. So they look like totally different radicals here. It doesn't look like we can combine them. Well, hold on. We can simplify square root of 27. Recall that 27 is 9 times 3, and 9 has a square root. The square root of 9 is 3 because 3 times 3 is 9. So now we have 3 square root 3's and 1 square root 3. We get 4 square root 3. Excuse me. So let's say we have something like this. What could we do here? Well, let's take a look at this 45x squared, or x cubed. Well, we can break this up into number and variable. This one times there. 9 times 5, because we can take the square root of 9. This one, we can do x squared times x. Because remember, x times x is x squared. So the square root of x squared will be x. So we'll get and we can bring these together here. 3 in the x, and the square root 5, square root x. And in the same root, we can bring them together. 3x, square root 5x. So that's what this becomes. Again, just focusing on this right here. So that's going to mean we're going to have 8 times 3x square root 5x plus square root 5x. So 8 times 3x will be 24x. Let me see what kind of answer they're looking for here. Okay, so this is what they want us to do. We have a square root 5x and a square root 5x in 2 places. So we have a variable, and there's a leading term here, but it's going to be easier to factor out the square root 5x. So we can do that. I'm treating this as a 1 times square root 5x. We factor. And that's going to be our answer. All right. So let's see. Let's say we have this. So what about this? Well, there's nothing. Oh, excuse me. There's nothing in this other place here, this other one, that we can take a cube root of. Really nothing we can do there. But this one we can do a little bit of work. And we could break it up. This we could rewrite. Now we can't take a cube root of y squared, really. I mean, you could get a rational exponent, but we're going to try to avoid those. But we can take a cube root of x cubed. X times x is x cubed, so the cube root of x cubed will be x. So we can combine these roots because they're the same root, they're a cube root. And so this will become that. All right, there we go. So we make that substitution. Multiply that. Now these we can actually add because 4x plus 5x will give us 9x. So we're going to get 9x cube root xy squared. And that's going to be your answer. If you're not so sure about that last move, what you could do is you could factor out, because this is cube root xy squared, cube root xy squared. So you could factor that out. And then what's 4x plus 5x? Well, 9x. And that's going to be our answer. Now, the next thing I want to talk about is called the quotient rule. And it's going to work like this. Now, again, we talked a little bit about it in 7.2, but I want to go through it again. We were kind of a little bit ahead of ourselves. So let's say we have a ratio of roots. Well, again, this is that rational exponent. So this is a to the 1 over n divided by b to the 1 over n. Then we can reverse that distribution rule for quotients. And that's a rule, again, that came from our rule for exponents, or amongst our rules for exponents. And then now we just take the root again. And there we go. And so we just take a shortcut here. And that's going to give us a quotient rule for roots. So again, we got to make sure the roots are the same, and then we can combine them, or we can take a root of a quotient and we can break it up. So for example, say we have this, we can break this up as square root of 19 over square root of 25. We know the square root of 25, that's 5. This is an irrational number, so we're just going to leave it. All right. And so that's going to be it. Well, let's take a look at another one. So what can we do here? Well, again, let's break this up. So let's take a look at this piecemeal. This one right here, really not much we can do with this. So we can just leave it like that. Let me see here in the text, is that what they want us to do? Oh no, they're gonna have us do a little bit more. I'm sorry, there's more we can do with this. And so this is what we can do. Let's work with this top one. We can rewrite this as x cubed times x squared. There actually is something we can do with this. This has a cube root. It's going to be just x. So we'll get x cube root of x squared. And that's the best we can do. Now for this one, this bottom part, again, we can break it up. Cube root of 125 is 5. Cube root of y cubed is going to be just y. So we get 5y. And that's going to be our answer. All right. Let's see. So let's go the other direction. Let's take two separate roots that are in a ratio and combine them. So let's say we have this. Square root of 200 over the square root of 10. Now we can combine these roots because they're the same root. And so what we'll get is square root of 200 over 10, or the square root of 20. And we can break this up into a number that has a square root. Sometimes we can't do this, but this one we can. Number with a square root and a number that doesn't. Or square root 4, square root 5, or 2, square root 5. And that's going to be our answer. All right. So let's say we have this one. Well, again, they're the same roots, square roots. So we're going to combine them into one. So what we can do here, 500 divided by 10 is 50. And this will be x. We can use our quotient rule for exponents. 3 minus a negative 1. I'm not going to worry about flipping this yet, though you could do it that way. You can flip it up to the top here, have x to the positive 1 times x cubed to give you x to the 4. You're going to get the same thing this way, but you could do it that way. This will be x to the 4. And we can break it up into number and variable. Now 50 we can write again as 25 times 2. And this here, the square root of x to the 4th, x squared gives x to the 4th. So the square root of this will be x squared. Or 5x squared, square root 2. And that's going to be our answer. Let's see. This one. Now, again, same roots. So that means we can make them into one big root. So we simplify on the inside. So this will come out to, let's see, 250 divided by 2, 100, 125. X to the 5 minus 3, y to the 3. So this will be x squared y cubed. Again, we can break things up. Now, we do have a cube root for 125. It's going to be 5. And the cube root for y cubed is y. So moving the non-cube root over, 5y cube root x squared. All right. So let's do one more. Let's say we've got this. And I should mention for this section, it makes a note here for the homework. Assume that all variables represent positive real numbers. So positive means we're not going to worry about division by 0, and we're not dealing with negative numbers. So what that means, if we take the even root, like the square root of x squared, we don't have to call it the absolute value of x. So all the variables are going to be positive. That means they're going to be positive numbers and not 0, actually, because we do want to avoid division by 0. So let's do one more. So once again, they're the same root. We can combine them under a single root. So what's going to happen here? Well, recall from chapter 5 the difference of cubes. I'll double check this just to make sure. All right. So what we can do is we can cancel the a minus b. This is the special form for difference of cubes. Well, the a minus b's will cancel, and so what we'll get and that's going to be our answer. So that's going to be 7.4. Again, any questions about this section, let me know. In 7.5, we're going to do more with multiplying radicals together. We'll be looking at FOILing. Again, we're going to be treating different radicals as like different terms. And again, if you have any questions, let me know.